Last, we have to connect this concept of electrolyte solutions, and non-electrolyte solutions for that matter, to electrical conductance, because that's what it all is about. We have electrolytes that have to do with electrical conductance of a solution. Does my solution conduct an electrical current? So when I talk about conductance, I don't mean heat conductance or something like that. I mean, I can conduct a lot of things, right? Heat is one example. But I mean electricity. I'm talking about, is electricity conducted in this context? Electric conductance. And before I do that, let's start with electric conductance as such, because not everybody has yet had the second physics class, E&M, and then let's connect the thing to solutions. So very, very simplistically speaking, let's prepare you for, actually that's lab 1 in the chemistry lab 124. It's about where you will measure electrical conductance if this was a normal semester. I don't know whether you still do. But if you were to do that, if you were to do lab 1, and lab 1 might still talk about electrical conductance. So the question is, before we talk about solutions, let's talk about normal electrical conductance, right? Let's talk about solids. In your phone, there's no solution. Every electrical conductance on the electrical parts in your phone are done with solids. And the parts that conduct electricity are made out of metal, right? Metal conducts electricity, and anything that is plastic or wood, or for that matter sodium chloride, simply any air, they don't conduct electricity, right? If they would, electricity would flow anywhere, but it doesn't. It flows only through metals. And the question is, why does it do that? So why does an electrical circuit looks like that? I have my battery here, and I need wires to go to the bulb. The electricity can't go from this negative terminal or from the positive terminal to the bulb just through the air. I need a wire to make this connection, and I need a wire for the electricity to come back. If I break this wire, the light will go out. Why is that? And the reason is electricity can only flow when there is an electrical charge, right? An electrical charge that can move about. So I have that here. Electrical current is a flow of electrical charge. So I need a flow of electrical charge. That is, then I call it an electrical current. If I have an electrical current, my bulb is shining. If I switch the light on, hey, the electrical charges flow. But for that, to be able for them to flow, I need something like mobile charges. So my requirement for that I can flip a switch and electricity will flow, I need mobile charges. So this is two things, right? First of all, I need charges. Second is I need mobile charges. They need to be able to flow somewhere else. They can't be charges that are kind of fixed in space to some extent. And I would like you to pause the video and write down a couple of charged objects. 4, maybe 6 you can remember from Chemistry 121. You had many in Chemistry 121. I just put 4, but you can write down many. Please do so. I hope you did. How many could you think of? I mean, very obvious is the electron and the proton. The The neutron is not charged, right? So those are the most basic electrically charged species. The electron is negative, the proton is charged positively, but then all the ions are of course charged, right? Every cation is charged positively, every anion is charged negatively, and you could just have said lithium plus, sodium plus, chromium, rubidium plus, cesium plus. Just go down the periodic table. Do it the lazy way. Or fluorine minus, chlorine minus, bromine minus, iodine minus. Go down the other way. So that's perfectly possible. And the question is, are these mobile in any context? So in a metal, the electrons are mobile. That's a very special object. In a metal, the electrons are forming a super covalent bond, so to speak. It's a super covalent bond because it's a covalent bond that is not between two atoms, but it's between all the atoms. And that means, and that kind of leads to this property that electrons can move through a metal. But that's special. Metals are very, very exceptional things. There's only so many in the periodic table, and there's not many other substances that do the same trick. Graphite is one, but there aren't many others. It's a very exceptional thing. Most other things are simply insulators. So there are many charges around. So we have the second part here. The charges bit is fulfilled because, hey, we have electrons, we have nuclei, they're all charged, but they can't move about really a long distance. They have to sit where they are in their atoms or in their ions, and they can't move from over larger distances. And that means electrical charge cannot really flow. Okay, so much for the electrical currents.